the city that never needed wires. At the beginning of the 20th century, cities were changing fast. Streets glowed for the first time. Factories hummed with electric motors. Power lines spread like veins across the land. Electricity had arrived. But one man believed this entire system was wrong. Nikola Tesla didn't just want better generators. He wanted no wires at all. Tesla believed electricity could be sent through the air, through the ground, through the planet itself. Not to power a single light, but to power entire cities. A world where buildings had no cables, streets had no power poles, energy flowed invisibly everywhere. Most people today assume this was fantasy, a brilliant mind drifting too far ahead. But Tesla wasn't guessing. He was experimenting, building, testing, and for a brief moment in history, a wireless electric city was not just an idea, it was under construction. This is not a story about science fiction. It's a story about a future that almost happened, a future powered not by wires, but by the Earth itself. To understand how close Tesla really came, we need to understand how he saw electricity, because Tesla didn't see it as a commodity, he saw it as a force of nature.
Tesla's vision of a wireless world. Nikola Tesla thought differently from almost everyone else of his time. While others focused on machines, Tesla focused on fields, invisible forces, energy moving through space. To Tesla, wires were a limitation, a crude solution. Why Tesla hated wires? Wires waste energy. They corrode, they break, they limit distance, they create monopolies. Tesla believed electricity should behave like radio waves, everywhere, accessible, shared. He imagined a world where energy flowed the same way information does today. No physical connection required. The Earth as a conductor. Tesla's most radical idea was simple to state. The Earth itself can conduct electricity, not just locally, globally. Tesla believed the planet could act like a massive electrical system, a resonant body. By injecting energy at the right frequency, that energy could travel through the ground and be tapped anywhere else. This wasn't magic, it was resonance. Resonance, Tesla's obsession. Resonance is what happens when a system vibrates at its natural frequency. Push a swing at the right moment, and small pushes create large motion. Tesla believed the Earth had natural electrical frequencies. If you matched them precisely, energy could travel with minimal loss. This idea consumed him. Early wireless power experiments. In the 1990s, Tesla demonstrated something shocking. He lit lamps without wires, across rooms, across stages. Crowds watched bulbs glow while not connected to anything. Tesla wasn't hiding batteries. He was using high-frequency alternating current, the energy coupled through space. The Tesla coil, more than a showpiece. Today, people see Tesla coils as spectacles, lightning arcs, crackling sparks, but to Tesla, they were prototypes, tools for generating high-voltage, high-frequency energy. This kind of energy behaved differently. It radiated, it induced currents, it moved without wires. Tesla believed this was the key to global power transmission. Beyond power, Tesla's unified vision. Wireless electricity was not a standalone idea. Tesla imagined a single global system. Wireless power, wireless communication, global synchronization, instant information transfer. In many ways, he predicted radio, Wi-Fi, and global communication. But he went further. He wanted power and information to share the same infrastructure. Free energy, the most misunderstood phrase. Tesla often spoke about free energy. This phrase has been abused ever since. Tesla did not mean energy created from nothing. He understood thermodynamics. He meant free access, not free creation. Energy would still be generated by power plants, but distribution would be universal. No wires, no meters, no regional control. Why this scared investors? This vision terrified financiers. How do you charge for energy that has no wires? How do you control distribution when anyone can access it? How do you build monopolies on invisible infrastructure? Tesla's dream was technically ambitious, but it was economically disruptive, and that mattered more. Tesla versus the industrial world. The industrial age was built on ownership. Power plants, transmission lines, meters, bills. Tesla's system removed the physical points of control. To him, this was progress. To industry, it was chaos. Still, Tesla pushed forward. Despite resistance, Tesla was convinced he was right. He believed wireless power was inevitable, that wires were temporary, and he was ready to prove it on the largest scale ever attempted. He would build a tower, not just a transmitter, but the first node of a global wireless energy network. It would rise from Long Island, and it would change everything. In the next part, we'll travel to that place, a half-finished structure that still stands as one of the most mysterious projects in the history of science. Wardenclyffe, Tesla's unfinished wireless city.
Wardenclyffe Tower, the city that was supposed to light the world. In 1901, on the north shore of Long Island, New York, construction began on something extraordinary. It didn't look like a power plant. It didn't look like a radio tower. It looked like a monument, a tall wooden structure topped with a massive metal dome. Tesla called it Wardenclyffe Tower, and according to him, this was not just a transmitter. It was the first station of a global wireless energy system. What Wardenclyffe was really meant to do. Most people are told Wardenclyffe was a radio tower. That is only half true. Tesla did intend to transmit signals, voice, data, images, but communication was only the beginning. The real purpose was power, wireless power. Tesla believed Wardenclyffe could transmit electricity through the earth, send energy through the atmosphere, deliver power anywhere on the planet. A city without wires would be the proof. Why Long Island? Tesla didn't choose the location randomly. Long Island had conductive soil, access to the Atlantic Ocean, and geological conditions Tesla believed were ideal. Tesla thought the Earth behaved like a giant electrical capacitor. The tower would inject energy into the ground. The planet itself would carry the signal. The underground secret. Most photos of Wardenclyffe only show the tower above ground, but the most important part was hidden below. Tesla built a deep underground shaft. Tunnels extended beneath the tower. Metal pipes were driven deep into the earth. Tesla believed grounding was essential. The energy would not radiate outward randomly. It would resonate through the earth. The dome was not decoration. The massive metal dome was not aesthetic. It was designed to control electrical discharge. Tesla planned to generate extremely high voltages, millions of volts. The dome helped distribute that energy without destroying the structure. Funding the impossible. Building Wardenclyffe required serious money. Tesla turned to one of the most powerful financiers of the era, J.P. Morgan. Morgan initially agreed to fund the project. Why? Because he believed Tesla was building a superior radio system. Wireless communication meant profit, transatlantic signals, commercial control. Tesla received about $150,000, a huge sum at the time. Construction began. Hope was high. The problem, Tesla couldn't hide. As construction progressed, Tesla's ambitions grew. He began speaking openly about wireless power, about free access, about global energy.
Morgan started asking questions. How will we meter it? Tesla had no answer. The moment everything changed. According to historical accounts, Tesla eventually told Morgan the truth. Wardenclyffe would transmit power, not just signals, and anyone could access it. Morgan reportedly replied with one sentence, "If anyone can draw on the power, where do we put the meter?" Shortly after, funding stopped completely. Why funding never returned? Tesla tried to find new investors, but the world had changed. Marconi successfully transmitted radio signals, cheaper, simpler, easier to control. Tesla's system looked risky, expensive, unproven, and most importantly, uncontrollable. No wires meant no ownership. Wardenclyffe stalls. Construction slowed, equipment sat unused. Tesla continued to experiment, but money was gone. The tower was never completed. In 1917, Wardenclyffe was demolished, sold for scrap metal. The dream ended quietly. Was it a scam? Some critics later claimed Tesla was delusional, that Wardenclyffe could never have worked. But the truth is more complex. Tesla was not wrong about everything. He understood resonance. He understood electromagnetic fields. He understood wireless transmission. But he underestimated something else: engineering reality versus vision. Tesla believed energy losses would be minimal. Modern science shows they would not have been. Wireless transmission over long distances is inefficient. Energy spreads, it dissipates. The Earth is conductive, but not perfectly. Tesla's system would have worked, but not at the scale he imagined. The real failure was timing. Tesla was early, too early. Materials were limited, electronics were primitive, control systems didn't exist. Even today, we struggle with wireless power efficiency. Tesla wasn't wrong about the direction, he was wrong about the decade. A city that almost was. For a brief moment, a different future was possible. Cities without power lines, energy everywhere, no visible infrastructure. Wardenclyffe stands as a reminder, not of failure, but of ambition. In the next part, we'll answer the most important question of all. What would a wireless electric city actually look like, and could it ever work safely, even today?
How a wireless electric city would actually work. To imagine a wireless electric city, we have to remove the myths first. Tesla was not talking about electricity magically floating everywhere. He was talking about controlled resonance, precise frequencies, specific pathways. Wireless power, in Tesla's mind, was not chaos, it was structure. The core idea: resonance, not radiation. Modern wireless devices use radiation. Energy spreads outward in all directions. That's inefficient. Most energy is lost. Tesla wanted something different. He wanted resonance. Resonance allows energy to move efficiently between systems tuned to the same frequency, just like pushing a swing at exactly the right moment. The Earth ionosphere system. Tesla believed Earth itself was part of the circuit. Between the ground and the ionosphere above exists a natural cavity. This cavity can resonate. Modern science confirms this. We call these natural frequencies Schumann resonances. Tesla didn't know the name, but he understood the concept. Injecting energy into the planet. In Tesla's system, power plants generate electricity. Energy is converted to high-frequency AC. Towers inject this energy into the Earth. The planet carries the signal. Receiving stations would extract that energy. No long-distance wires, no over-amp lines. Why towers were essential. Wardenclyffe wasn't meant to stand alone. Tesla imagined multiple towers, strategically placed. Each tower would maintain resonance, amplify signals, and stabilize transmission. Think of them as nodes in a global energy web. How a city would receive power.
Buildings wouldn't connect by wires. Instead, they would use grounded receivers, tuned circuits, and resonant coils. If tuned correctly, they would draw energy from the Earth's oscillations. Lights would turn on without plugs. Motors would run without cables. Safety, Tesla's biggest challenge. This is where fantasy ends. High voltage, high frequency energy is dangerous. Tesla believed high frequencies were safer for humans, and to some extent he was right. High frequency currents tend to travel over surfaces. They don't penetrate deeply, but city-scale power is a different story. Interference everywhere. A wireless electric city would flood the environment with electromagnetic energy. That creates problems. Interference with communication, effects on sensitive electronics, potential biological concerns. Modern regulations exist because of these risks. Tesla lived before we understood them fully. Energy loss, the hard limit. This is where physics becomes unforgiving. Energy transmitted wirelessly always spreads. Some is absorbed by soil, some is lost as heat, some radiates away. At small scales, this is manageable. At city scale, losses become massive. Tesla underestimated this. Control and stability problems. Power grids today are tightly controlled. Frequency stability, load balancing, instant adjustments. Tesla's system lacked feedback systems, real-time control, precision electronics. A wireless grid without control can become unstable. That instability could damage equipment, or worse. What Tesla got right. Despite the limits, Tesla wasn't wrong about everything. Modern science uses his ideas: wireless charging, resonant inductive coupling, radio frequency power transfer. Even space-based solar power uses similar principles. Tesla predicted the direction, not the final design. Why we still don't have wireless cities? The answer isn't conspiracy, it's efficiency. Wires are incredibly effective. They lose very little energy. They're easy to control. They're predictable. Wireless power trades efficiency for convenience. At small scales, that's acceptable. At city scales, it's not. The realistic outcome. If Tesla had succeeded, cities would not glow magically. They would require strict zoning, limited power density, specialized receivers, not free energy everywhere, but something closer to selective wireless infrastructure. The city that could have been. Tesla imagined perfection. Reality demands compromise. His wireless city would have worked in parts, not globally, not freely, but enough to change history. And that raises a haunting question. If Tesla had better materials, better electronics, and modern control systems, could a wireless electric city exist today? That's what we'll explore next.
Could a wireless electric city work today? More than a century after Tesla's vision, the world looks very different. We have semiconductors, supercomputers, artificial intelligence, materials Tesla could never imagine. So the question becomes unavoidable. Was Tesla simply too early? Or was the idea itself flawed? What modern technology changes? Tesla worked in an era without digital control systems, real-time feedback, precision electronics, advanced materials. Today, those limitations are gone. Modern power systems can respond in milliseconds. They can detect instability instantly. They can adapt. This changes everything. Wireless power exists in pieces. Wireless electricity is no longer theoretical. We already use it. Wireless phone charging, electric toothbrushes, medical implants, RFID systems. These systems use resonant inductive coupling, the same principle Tesla explored. But they operate over short distances, centimeters, not kilometers. Scaling is the hard part. The challenge is not wireless power, it's scale. Power increases with demand, losses increase with distance. To power a city wirelessly, you must transmit enormous energy. That raises serious issues.
safety in a wireless city. High-power electromagnetic fields can affect electronics, medical devices, and communication systems. Modern safety standards exist for a reason. A wireless city would require strict power limits, controlled frequency bands, shielded zones, and smart receivers. This isn't impossible, but it's complex. AI-controlled power distribution. This is where Tesla's idea becomes more plausible. AI systems can balance loads instantly, detect interference, adjust frequencies dynamically, prevent runaway resonance. Tesla lacked this ability. We don't. An AI-managed wireless grid could maintain stability far better than early 1900s systems. Energy beaming, a modern alternative. Instead of ground resonance, modern engineers explore energy beaming using microwaves, lasers. Power is transmitted from a source to a receiver. This is already being tested for drones and satellites. It's directional, controlled, safer than global resonance. Space-based solar power. One modern idea comes very close to Tesla's dream. Solar panels in space collect energy continuously. That energy is beamed to Earth as microwaves. No wires, no fuel, no atmospheric loss at the source. The challenges are engineering, not physics. Why we still use wires. Despite everything, wires remain dominant. They are efficient, cheap, reliable, easy to regulate. Wireless power struggles to compete on efficiency. Physics still demands trade-offs. The control problem remains. Wireless energy is harder to meter, harder to regulate, harder to monetize. Power companies need predictability. Governments need safety. Consumers need reliability. Tesla's vision disrupted all three. A hybrid future. The most realistic future is not wireless instead of wires, it's wireless alongside wires. Examples: wireless charging streets, cable-free buildings, emergency power zones, remote infrastructure. Not free global energy, but selective wireless systems. Tesla's legacy in today's world. Tesla wasn't wrong, he was incomplete. He imagined the destination, not the full map. Modern science confirms wireless power is possible. Resonance is real. Earth-atmosphere systems exist. But it also shows losses are unavoidable. Control is essential. Safety cannot be ignored. The city Tesla wanted versus the city we can build. Tesla dreamed of abundance, access, equality. Modern systems focus on efficiency, control, security. The tension between these goals still defines energy politics today. The final question before the end. Tesla asked, why should power be owned? Modern society still hasn't answered, because the barrier was never just science, it was economics, power structures, human systems. And that leads us to the final reflection. Tesla didn't fail because his ideas were impossible. He failed because the world was not ready to change. In the final part, we'll step back from equations and engineering and ask what Tesla's wireless city really represented. Not just a technology, but a philosophy.
The future Tesla never lived to see. Nikola Tesla did not die surrounded by success. He died alone, in a small hotel room, his ideas scattered across notebooks the world barely understood. Yet today, we live in a world shaped by his thinking. Alternating current powers our cities, radio waves fill the air, wireless signals connect continents. Tesla imagined all of this before the world had the language to describe it. His dream of a wireless electric city was not just about technology, it was about access. He believed energy should be as natural as sunlight, available, shared, unrestricted by distance or ownership. That idea frightened powerful people, not because it was impossible,
but because it was uncontrollable. Tesla didn't fail because the science was wrong. He failed because the system was. The world chose efficiency over abundance, control over openness, profit over possibility. And perhaps that choice was necessary. Perhaps the technology was too immature. Perhaps the risks were too great. But one question still lingers. What kind of world would we live in if Tesla's city had been built? A world without wires in the sky, a world where power flowed silently through the ground beneath our feet. Today, as we explore wireless charging, energy beaming, and space-based power, Tesla's ideas no longer sound impossible. They sound early. Not every future arrives on time. Some wait until humanity catches up. Tesla looked at electricity and saw freedom. Whether we ever build a wireless city is still uncertain, but the question Tesla asked remains unanswered. Should the forces of nature belong to a few or to everyone?